The waters surrounding Antarctica are believed to be among the last places on Earth to be seemingly unaffected by global warming. But why the southern pole's waters have been unaffected, unlike those in the Arctic, has puzzled climate scientists and oceanographers. Now researchers believe they have solved the conundrum. They say ocean currents dragging frigid water from the deep may explain why the Antarctic seas have remained the same temperature, while much of the rest of the world has warmed. Scientists at the University of Washington and the Massachusetts Institute of Technology have explained the inconsistent pattern of warming in the journal Nature Geoscience, which is often seized on by climate deniers as proof global warming is not man-made. Observations and climate models show the unique currents around Antarctica continually pull up deep, centuries-old water to the surface. This seawater last touched Earth's atmosphere before the machine age and so has not been warmed by the atmosphere since fossil fuels began contributing to greenhouse gases. With rising carbon dioxide you would expect more warming at both poles, but we only see it at one of the poles, so something else must be going on, said lead author Kyle Armour, an assistant professor of oceanography and of atmospheric sciences at the University of Washington. We show that it's for really simple reasons, and ocean currents are the hero here. Gale force westerly winds that constantly whip around Antarctica act to push surface water north, cause water from up to 2 miles below to be pulled up to the surface. The Southern Ocean's water comes from such great depths, and from sources that are so distant, that it will take centuries before the water reaching the surface has experienced modern global warming. While in other waters, such as the west coast of the Americas and the equator, seawater is drawn up from a few hundred meters below the surface, the action of the currents does not have the same effect. The Southern Ocean is unique because it's bringing water up from several thousand meters, Dr. Armour said. It's really deep, old water that's coming up to the surface, all around the continent. You have a lot of water coming to the surface, and that water hasn't seen the atmosphere for hundreds of years. The water surfacing off Antarctica last reached Earth's atmosphere centuries ago in the North Atlantic. It then sank and followed winding paths through the world's oceans before resurfacing off Antarctica, hundreds or even 1,000 years later. The team of experts used data from Argo observational floats and other instruments to trace the path of the missing heat. Delayed warming of the Antarctic Ocean is commonly seen in global climate models. But experts mistakenly this was because of churning, frigid seas pushing extra heat downwards. The old idea was that heat taken up at the surface would just mix downward, and that's the reason for the slow warming, Dr. Armour said. But the observations show that heat is actually being carried away from Antarctica, northward along the surface. In the Atlantic, the northward flow of the ocean's surface continues all the way to the Arctic. The study used ice in model simulations to show that seawater that has experienced the most climate change tends to clump up around the North Pole. This is another reason why the Arctic's ocean and sea ice are bearing the brunt of global warming, while Antarctica is largely oblivious. Dr. Armour explained, the oceans are acting to enhance warming in the Arctic while damping warming around Antarctica. You can't directly compare warming at the poles, because it's occurring on top of very different ocean circulations. Knowing where the extra heat trapped by greenhouse gases goes, and identifying why the poles are warming at different rates, will help to better predict temperatures in the future. When we hear the term global warming, we think of warming everywhere at the same rate, Dr. Armour said. We are moving away from this idea of global warming and more toward the idea of regional patterns of warming, which are strongly shaped by ocean currents.